This presentation will cover attribute data. Now, features within a GIS data set have an inherent connection to attributes, or at least the ability to enter attributes in to describe them further. There are a wide variety of categories of attribute data, and most of the time when people think about GIS analysis, they think of the spatial side of things, and of course that's a very powerful part of a GIS when it comes to what it can do for problem solving. But at the same time, though, when you look at the amount of attribute data that you can put into a GIS to help describe features, and also just the ability to query attributes and get answers back, you'll see that attribute analysis again, it's sort of the other side of the street. It's not spatial analysis, but it is pretty effective, though. Now, one general quality of data that you'll find within attribute tables, and by the way, this isn't the only one. There's a whole world out there of data just itching to be put into an attribute table for analysis. However, though, one that's quite common, everybody, is socioeconomic data. Data about humans, human activities, and the space and or structures used to conduct human activities. So, what are we looking at? That which is human, and also describing the humans, and also seeing just some of the ways that they may change the landscape a little bit. Now, some examples of socioeconomic data you see here in these general categories, and some of them are pretty straightforward. You expect demographics, of course, to be associated with socioeconomic data, economics, of course. However, things also, everybody, like, for instance, migration, okay, the movement of people from point A to point B, but also retailing, too. That also falls within socioeconomic data. So you're going to see that the net is thrown out pretty wide when it comes to this kind of a category of information that you can put within the attribute tables. Now, no matter what kind of attribute data you're going to be entering, let's see whether or not we can start to maybe create some more general categories of this data. Now, disaggregate data is about individuals or single entities. You are describing, again, looking at this data, the definition here, you're looking at a single thing that you are going to be describing. Some of the examples presented: a person's age, gender, income, gross sales, number of employees for a retail store, registration number and model type for a single vehicle. Well, the first one seems pretty straightforward. You're describing a person. But now the second one, though, you say, hey, by the way, you're looking at gross sales, number of employees. Sounds like you got more than one thing you're looking at. No, not really, because you're looking at a retail store and describing that retail store. Now, the third one, registration number, model type for a single vehicle. Think about it. The claim to fame that your driver's license has, or license plate. Supposedly, both those are they're the only ones in the world with those particular numbers and letters describing each. So, see, you are a special person. As soon as you get that driver's license or you register your car, just think about it. The only license plate in the world like that, supposedly. And, oh, by the way, if I get excited about stuff like this, that just shows you just what a boring life I have. Okay, now let's take it now one step further. If it's not dealing with describing a single entity, well, that means the other side of this street is going to be aggregated data, describing a group of observations with the grouping made on a defined criteria. Okay, now we're finally going to start grouping things together. Now, the examples provided for aggregate data: geographical spatial units, census tracts, school districts, time interval, number of persons leaving an area in 5 years, socioeconomic grouping, persons ages 18 to 22. Well, geographical spatial units, in particular, I'd like to use the example of the U.S. Census. From the very beginning of the U.S. Census, it was geographical in nature. They were aggregating information based upon where people live, and of course, they were asking about what do you do for a living, and maybe how many people live here, and things like that. And by the way, Of course, many nations do that too. I just want to make it sound like the United States is the one that started this. But still, any census, you're looking at trying to aggregate because you can't describe every individual. You got to talk about the group. Now, for time interval, number of persons leaving an area in 5 years. The reason that's aggregated, everybody, is even though it's leaving an area in 5 years, you're going to be looking at aggregating time data. Okay, looking at this area and saying, okay, looking at in 5 years, you're bringing this data together in an aggregated manner. Now, socioeconomic grouping. One of the things that is, well, seems like the destiny for all of us is that society likes to categorize us, and whatever age group you're in, well, the business world already knows how we like to dress and the kind of music that we listen to, and even the kind of cars that we like to drive more so at certain times in our lives versus other times. However, though, if somebody would like to give me a sports car, I could live with that too. But supposedly, at my age group, I'm supposedly more conservative. Well, okay, so be it. But still, you can take an age grouping, and then you can aggregate it, and then also see some qualities with it. Now, let's add another dimension to these different general categories of data that we're gathering. Cross-sectional data gives information on many areas for the same single slice or interval of time. What kind of examples do we have for this? Well, average income in census tracts of Los Angeles for 1988, numbers migrating out of each state in the period 1971-1975. Look at cross-sectional data as if you have a magic data camera, okay? You point it at an area, you press the button, and like for instance for the Los Angeles example, everybody, you're looking at all of Los Angeles, okay? The census tracts. You press a button and all of a sudden the magic camera just sort of grabs all that geographic information, but it takes only one picture. Just like for the number migrating out of each state in the period 1971-1975, okay, your magic camera also is temporal, has the ability to look at time, but you're going to get a single result, and thus cross-sectional. So now, the other side of that coin is longitudinal data. Gives information on one or more areas for a series of times. Now, kind of related to that LA example that was just shared. Average income for the state of New York from 1970 to 2000 by year. Now you say, okay, well, you pulled out the magic camera again and you said, okay, well, you just looked at the state of New York and you're looking at average income. Isn't that cross-sectional? No, it's not. The reason being is that the way that this is phrased, 1970 to 2000 by year, that means that you're going to press the button on that magic camera every year from 1970 to 2000, and you're going to get different measurements of the landscape when it comes to average income each year. So there is a difference, everybody. Longitudinal, you're coming back to something. You're going to revisit the measurement. And by the way, one thing I always get a kick out of when it comes to people talking about their research, they love in society when they talk about research, they say, we did a longitudinal study. And if you don't know what that is, oh, that sounds so important, doesn't it? Like, oh, wow, you must be really pulling out the statistics textbooks on this one. No, all it means is that we're revisiting whatever it is that we're taking measurements of or doing whatever. So now, just to summarize, cross-sectional versus longitudinal. Cross-sectional, you get one measurement. Okay, even though it's over maybe a large area. Longitudinal, you're going to be revisiting. And also, everybody, disaggregated versus aggregated. When it's disaggregated, you're looking at a single entity. And aggregated, you're grouping. So, you can mix these up now. You could say, hey, by the way, I'm going to do a longitudinal longitudinal study, and the data that I'll be looking at is going to be aggregated. So you can kind of mix this up a little bit. But these are some nice general categories to in your mind to kind of look at how the attribute information is being, the categories of attribute information that are being put into the tables. So now the question is, where do we get this socioeconomic data? Well, maybe you're a very productive person, very industrious, and you're going to gather it on your own. Now, field surveys. One of the reasons that you're going to see that, when you get your PhD and you're doing your dissertation research, that last major hurdle that you have to go through, quite often they say that's some of your best research because you're taking the time to gather quite often your own data, and so that simply does, it takes a lot of time. Well, if you're going to be doing this, say field surveys, and examples here, door-to-door, phone, mail, whatever, please just make sure that you have a rationale. You can go into the literature and say, by the way, if you're going to do field surveys, what is the standard approach? And in many universities, in geography programs, there are courses in how to do proper field surveys. Now, an example I'd like to share with you is when I was a doctoral student, I got a call from a major magazine in the United States. I'm not going to say which one because I don't want to get sued for what I'm about to say. But they said, sir, this is the blah, blah, blah magazine, census or question. The bottom line is this. I'm sorry, I'm trying to remember just how the gentleman said it to me. But the bottom line is that they're going to ask my opinions that were going to be put into maps that they're going to be generating for the magazine. And I was like, hey, great! I'm gonna finally have some input into these maps or these graphs that you generate. Well, the man said, by the way, what is your zip code? And I'm sorry, not zip code, but the prefix for the area code for my phone number. And what happened is in the area that I was living in, they had just recently changed it. And I told him what it was, and he said, that does not match our database, and so therefore I cannot ask you these questions for this survey. And okay, I put the phone down, but I thought to myself, they didn't update their database when it came to area codes in the United States. And that means there are whole regions that they didn't bring into the survey. Yeah, that's bias. That's big bias. So please just make sure you have all your ducks in a row when it comes to making sure you get samples in a systematic way. Now, government statistics. You're going to see that, in particular, the U.S. government as an example, that there is a lot of data out there. And quite often there's a mandate that they have to follow, that they have to share it with the general public. Now, if they're going to ask you for some extra money because they're going to put it on a disk or something like that, okay, they do that every now and then. But at least at the foundation level, they're supposed to be giving this to you for free. And I'm sure there are many other governments out there that they're also generous with the data. And so the government data is quite often it's good stuff. And also, since they're looking at society as a whole, you quite often get entire population data versus just specific location. Now, when it comes to government administrative records, here's where quite often they draw the line, and that is if you ask for tax records, auto registrations. I mean, this stuff that you cringe that some stranger would have access to. The way they get around that is that if they aggregate the data, if they take out your name, anything identifying you. But let's just say we're looking at a neighborhood, and they said, okay, so what is the average household income for that neighborhood? Okay, they give a general value, an average. Okay. Your data is protected, and whomever wanted the data, they have something. But that's usually the way they handle that. So they've been doing this for quite a while, and they're pretty good at it. Now, when it comes to the private sector, I went to a meeting once in Chicago dealing with the use of GIS in business, and I was given a real education when it came to just how much data is out there generated by retailers. And quite often they charge really good money for this data, just an enormous amount out there. And so it's there too, but quite often you got to pay for it. Now, when it comes to government data and customization of it, there's an interesting fuzzy gray line between government data and private sector data. But there are quite a few private sector organizations. They take government data and they manipulate it, they change it, they augment it, and to the point where they could say it's their stuff. And just please note that whenever you're using government data, it's really a good idea to at least give them credit or say, hey, this is where that we initially got this this data from, because you might open yourself up to some legal issues if you don't do that. Now, in general, we call this data secondary data collected by another group. Now, since you're not the one who's running around conducting a survey, taking readings, whatever, it's often cheaper than if you had to go out and actually do it yourself. Okay, that's common sense. Now, documentation quality usually high. You can thank the internet for this, because when it came to GIS data, with the internet we were able to share information very quickly, and there was sort of this movement that took place not that long ago where they because there's so much information flowing around, metadata, especially when it came to data that the U.S. government was working with, it became sort of a requirement in many cases. And there are even websites you can go out to where you can create metadata reports, or even within, say, for instance, ArcMap, you have the ability to simply enter in information and create metadata. Now, data quality varying. You get what you pay for, and if you didn't spend a dime, everybody, okay, you know the rules. Quite often, when people were developing some significant data sets that were being used by the U.S. government, I'm not going to throw out any agency names, but purchasing data from the lowest bidder, because, well, that's life, okay? They didn't want to spend lots of money on any data. And so there's some data out there that is just top-notch, created by scientists, and there's some other data out there that you kind of wonder if the company is still in business. So that's where the metadata is important. Now, conversion may be necessary for use by GIS. You never know. Sometimes there's some old stuff out there that you have to work with. And by the way, it doesn't have to be old stuff either. You'll see even within ArcMap, there are various operations for conversion just because. Okay, it's not in the right format that you need it in. Okay, so you run it through conversion. So now with all this talk about metadata, what is it? Everybody, metadata is data that describes data. And actually they were throwing around metadata, the term, in various ways at a meeting I went to recently. But the bottom line is this. Used to ascertain data quality and reliability, you just want to describe the data. Now, may I say to you that this part of GIS could be as dry as dust. Okay, wow, I'm going to create metadata. How exciting could that get? Life is so wonderful, living on the edge. You'll be surprised how metadata is important to you when you work with GIS, everybody, because if you use data and there was something wrong with it, something inherently wrong, and you didn't do your research, bad things can happen. Now, some general components of metadata you're going to find. Okay, identification. Okay, just tell me what it is. Data quality information. I once worked on a project where we did our very best to create GIS data to the best quality that we could, but there are inherently some things that we had no control over. And so what we did is we came clean in the metadata and say, hey, by the way, this data is reliable, within like plus or minus 100 feet. And so that is what the person who's going to use this data needs to know, okay, when it comes to data quality. Spatial data organization information, spatial reference, entity attribute information, distribution information, all these things important when it comes to describing the data. And so please, whenever you're going to be downloading or using some GIS data, keep the data, keep metadata. They have a link to, here's the metadata. Download that PDF, download or whatever format it's in. Print it off or whatever. So that way, when somebody calls you out on the mat and they say, "Hey, this was how accurate is this, or when was this created, or something like that," have that information readily available. So that way, well, it protects you and saves you some embarrassment. Now, looking at things from the technical side, here you see a example of the feature connection with attributes that are describing those features. And here you see several countries within Africa, and within the attribute table, you see a couple of fields of information describing them. Now, attribute table or tables are relational databases, and you could look that up a little bit more on the web if you want some more information about relational databases. But essentially, it has the ability to create bridges between different tables of information, and, well, quite functional. The table is comprised of fields and records. Fields, if you're looking at the columns of general categories, that's what we're looking at. Records, the individual records that comprise the attribute table. For all feature found in the GIS, there is a direct connection with the attribute table, which I just mentioned before. Now, please note, when you create attribute table fields and you're going to be entering in data, please note that it's not one size fits all when it comes to data types. You actually have to identify the kind of data, the category of data that you're going to be entering in. So just please note that as you work with GIS, just be aware of that, because if you create a attribute field and you misidentify the data, it could come back to haunt you when it comes to trying to do operations. Now, with relational databases, there's going to be a bridge that you're going to be having to create between one attribute table and another. But the general theme is this: there has to be something in one field that is the same in within one attribute table for some data that is the same in some other data that you're looking at. Now, let's look at the kind of relationships you can set up within a GIS. Three of the basic relationships that you can set up: one-to-one, many-to-one, and one-to-many. And by the way, the one that solves all problems is one-to-one. Whatever record you have in one table, you have in another table. And by the way, the reason you're doing this in the first place is that just because you bring the data into your GIS, it doesn't mean that it all knows how to talk to each other. Between attribute tables, you have to set up relationships. Now, the second one you see here, many-to-one, you see that from the table of origin, or aka also the destination table, you're going to see that there are many of something, several of something, and they affiliate themselves with just one of something similar. In this example that you see here, store number 204. Well, there are several different records that are identified with store number 204, and in another table looks like there was phone information and address information. So that was a way to connect that information with the other attribute table. And finally, one-to-many. Now, here again, you're looking at from the destination table. You have one of something. However, though, in the next attribute table you want to connect to, there are a lot of them. Now, a very common way of connecting tables together, joining tables. Okay, you're going to look at the common field. Okay, there's got to be something that they both have in common with each other. And the relationships that you can use, one-to-one, which again, that's universal. That could be used for just about anything. And many-to-one. So from the destination table, you have many of things, or several things, connecting to one of something in another attribute table. Now, when you do a join and it's successful, you're going to see that the result looks like you created a brand new table. suddenly it's going to look like both attribute tables for both GIS data layers suddenly merge together, and you say, wow, that looks really good. I've created something brand new. Well, yes and no. GIS data is, of course, now it's being presented as sort of being aggregated together. However, though, a GIS system it doesn't have redundancy within it. So those tables are still separated, but they look like they're together. Now you can only join two tables together. That's one limitation of joining tables. And well, also when you at least at the point that I'm making this video, that you can save a project and you can come back and you'll see the join is still there. However, though, at the very end of the day, when you finally say, well, remove the project file, or you break the join, everything looks like as if you first started. The attribute tables for both GIS data layers will be separated. Now when it comes to relating tables, you'll see the relationship can be one-to-one, again universal, but now it's one-to-many from the destination table. And you can also connect more than one table, so you can actually connect several of them together, and that's a good thing. Now, one of the limitations, of course, one of the limitations to share with you is that you can't save or relate. Again, at least from the time I'm making this video, that's not the case. And if it changes, well, then I'll have to change this video. But that's just a significant limitation of relating tables, that the relates break up at the end of your work session. And so now, everybody, what do we do with all these attributes? Welcome to Tabular Queries, and this is a workhorse of GIS. Tabular steps towards spatial analysis. Quite often, tabular queries are a precursor to spatial analysis, because you got to know what it is you're going to be comparing with when it comes to relationships in space. Method of inventorying data. You simply want to know, hey, tell me about the stuff that's within the attribute table. What qualities do certain things have? Okay, that's actually a pretty powerful thing to do. And you're going to see when it comes to the queries, there's a variety of ways that you could do this. So we're going to leave that for exercise sake to go further into that. Major thing to keep in mind, you can create some very elaborate statements when it comes to querying data. Please make sure that you have the right layers identified, or else you're going to have a headache. Think through the statement. Don't think of it in terms of, say, creating an English sentence, okay? You're going to, as you get more familiar with querying data, you're going to see that there is a manner in which you're going to have to ask the question. So that'll come with experience. And by the way, syntax problems, when there's a comma that's in the wrong place or an extra space, quite often the system will bail on you, and you're going to wonder where is the error. And at the time that I'm making this video, there is no way to highlight when there is some kind of a syntax problem. And, well, okay, maybe in another generation of the software. And here, everybody, is a image of the select by attributes operation found within ArcMap. And here's a simple statement that was created. You're going to see that well, it's all pretty straightforward, and it is your way of accessing a lot of attribute information and doing some very simple and also effective queries. And that concludes the discussion on attribute information. There's still probably much more that could be said, but this was just a general welcome to attribute data and some of its general qualities. The next step, everybody, when it comes to analysis, would be spatial analysis. And that is really where things get fun when it comes to the use of GIS. Thank you.